Like Jeff, I'm also a loud Irishman. Where'd he go? So about a month ago, Rich Costello, a good friend and colleague. Everyone know Rich here? So Rich, very well-respected professional, asked me if I'd do a presentation for you guys, and I said, sure, absolutely, whatever you need, Rich. And I said, well, what's it about? He says, well, my colleague Kathy's going to contact you. She sent me an email the next day, said, okay, you're going to be presenting on the Internet of Things and its impact on energy conservation. I said, perfect, great. Replied immediately, looking forward to it. See you there. Hit send. And then I sat back in my chair and I said to myself, what in the hell is the Internet of Things? Now, I know what the Internet of Things is, and I think that most of you know what it is or have a sense of what it is. But what I want to do today to start out is to really kind of maybe expand on that definition of the Internet of Things, which I'm going to refer to as IoT for brevity. What I'm also going to do is describe how my company, Transformative Wave, is able to deliver some pretty compelling and unique value to the marketplace because of the Internet of Things. So I'm going to try to provide some context and give you some specific examples. And then finally, toward the end, I'm going to try to really draw some conclusions about that specifically, and then maybe make some forward-looking statements and talk about some potential trends as in regards to energy conservation, building automation, and the Internet of Things. Okay, so most of the definitions, and this is a pretty concise and fair definition, ecosystem of connected devices and nodes enabled by electronics to communicate, collect, and exchange data. Most of the definitions of the Internet of Things are always kind of focused on the things and nothing more than that. And I think that it's not just these things, it's not just the devices, it's not just phones, it's not just computers, it's not just sensors, it's not just rooftop package units. There are other things that comprise the IoT. I'm going to try to make this interactive. Can anyone give me some quick examples of what those things may or may not be? We just heard about some of them. Networks, right? Yeah, actually, security. So let me just pull this up and I'll go through what I kind of see as what some of these things might be. So we have networks, and when I say networks, we mean both public and private, both wired and wireless. We're talking about LANs, WANs, VPNs, and of course, processors. So we have some devices in the Internet of Things, like our phone. This has a very powerful processor, but many devices have no processing power at all. Therefore, we have to make those devices valuable and connected, we have to have processing power somewhere else. So that somewhere else, typically, at least in my world, is cloud. So we have both data storage and processing that can either happen on a device level, or in the cloud, or remote systems, or both. And then, of course, we heard a lot about this today, is protocols. You know, these standards-based protocols and services, many of them you're familiar with. So it's really just a mismatch of all of these pipes in ways that we can connect. Some are standards-based and some are proprietary. So let me ask you, is proprietary okay? Raise your hand if you think it's okay. Raise your hand if you don't think it's okay. Okay, so we're split, as probably are most people. At the end of the day, none of these things work, whether they're proprietary or otherwise, without these, right? So the Internet of Things wouldn't really exist today without these. And you even heard some specific examples about how his company is creating unique value with their wireless data protocol, low band RF, for specific reasons. But certainly their technology isn't going to exist in a box, otherwise they have no way to bring it to market. So they offer software development kits and APIs so that all things can talk to each other. So I think it's important to kind of point that out just for context. So what I'm going to do today is I'm going to talk about my company's Catalyst solution, which is a retrofit solution for rooftop package HVAC systems. So let me tell you a little bit about my company. We've been doing this for about 10 years. This technology is fully commercialized, and I'll show you my customer list will really kind of drive the point home in a moment. But basically, a preponderance of buildings in North America anyway are heated, cooled, and ventilated with rooftop package units. And I assume that most people understand what they are and how they operate. They're pretty simple machines. And the reason there are so many of them is that they're cheap, and it's probably easy to design heating, cooling in the building around them. The downside of that is that they're usually oversized. We're usually designing to the worst case heat load condition, and thus most of the time they're operating, their energy use is excessive. So they're typically oversized, and they're usually not properly controlled. They're pretty much invisible, or their operation is invisible up on the roof. So we really don't know from time to time what the condition of those units are. They have a lot of moving parts, and they seem to constantly be in a state of failure and disrepair. So without any visibility of those units, it's costing us a lot of money in terms of energy, and it's also going to cost us a lot of money in terms of keeping them working properly over time through preventative maintenance. We believe at Transformative Wave that in spite of us heating, cooling, and ventilating with rooftop package units, we should be able to heat and cool buildings at a much lower cost. And we also believe that these HVAC assets should be accountable to the facility operator. And that's why we've come up with this catalyst solution, which you'll hear some more about in some detail just in a couple of moments. Here is just a short list of what I would say are some of our more recognizable customers. And I show this list for a couple of different reasons. One, look at all the great companies we're doing business with and delivering value for, Transformative Wave. But all these companies, as you might expect, have very different types of operations, different vertical markets, and as you would expect, they all operate in different climate zones. For example, Whole Foods is standardized on our energy conservation and control platform, so it's installed in every Whole Foods market in North America. Yet, like all these other customers, they're really getting the same value. So we have the ability with our catalyst solution to deliver this value in a very consistent and predictable way. And finally, for our purposes today, if you don't think IoT is already kind of penetrated the built environment, well, and I bet these guys weren't the first into the water. So we're already there. This is just forward-looking things. There's a lot of technology already in buildings that is leveraging the IoT, and specifically in this case, through the use of our catalyst solution. Again, we've been doing this for a very long time. This has been vetted over and over again by anyone that you can possibly think of, including most major utilities, some of which actually have prescriptive programs for our catalyst solution, Department of Energy, all of these case studies, and the mountain of data, third party is available on our website, and very transparent about the claims we make in terms of energy conservation, although it's it's about more than just energy conservation, which we'll see in a moment. Before I get into what it is and how it works, the nuts and bolts, are there any questions about anything that I've said so far? Okay, perfect. So the catalyst, basically what the catalyst is, it's a kit. It's a design build kit for rooftop package units. When we apply the catalyst to a building, we design and build a kit for each individual rooftop package unit based on its specifications and its existing control. And what we're doing in a nutshell is we're putting a smart controller inside the rooftop package unit. We are replacing the outside air sensor and putting a new one on. We are adding a supplier sensor, return air sensor, and a CO2 sensor. We're also taking control of the fan drive with a variable frequency drive for the supplier, and we're also tying into the outside air damper, otherwise known as an economizer. So we're basically have full takeover of the unit. And all we're doing on a very simple level as a standalone, let's keep this standalone for a moment for context. There's some control in the building that is sending commands to this unit. It could be a thermostat, it could be a BMS. The command is very simple. Run the fan for ventilation during scheduled hours, run heating, and run cooling. And that's what these units do. All we're doing is we're intercepting those commands from the existing control inside the unit, and we're applying advanced sequences of operation that allow us to provide the ventilation and comfort that's being asked for, just at a much lower cost. And we're doing that in three very simple ways. We're doing a very basic fan speed operation. So instead of running the supply fan at 100% all the time, as per code during scheduled hours, we're actually running the fan at discrete speeds. By default, 40% in ventilation mode, 75% in heat one, cool one, and 90% in heat two, cool two. So we're able to deliver and ventilate, really match the need for ventilation with the fan speed. So we're able to do that because and this is important, we have synchronous control over the supplier fan and the outside air damper. So anytime that we slow the fan down below 100%, we're always making a calculation so that we can open up that outside air damper so that we're always bringing in the correct outside air volume. Does that make sense? Yes.
So what I'm most curious about is feedback. There's a major problem out there that economizers are not maintained, and in one California study, 60% of the economizers were not working. They were either stuck open or stuck closed. What intelligence does your product bring in to alert people to the fact that the economizer is not working as intended?
I'm going to get to that in a moment, and this guy is not a ringer because it's a very important
Right, and
part.
the other thing you failed to mention is if you cut the energy speed, you cut the volume of the fan, because there's a cube function of energy, half the speed, half the volume uses 1/8 the energy. So there's a huge energy grab available if you can slow the energy.
Absolutely. Thank you so much for pointing that out. So specifically, let's say if we operate that fan at 40% versus 100%, the actual energy savings is 90% of what the base case would have been at 100%. So the fan affinity laws tell us that these fan speed savings are very powerful, and the savings aren't linear. In fact, they're a lot more than you would expect. Excellent. Thank you very much. The other way that we save energy is we enhance the economizer sequence, which typically, as found, is a single point of changeover. So say like 59 degrees. If there's a call for mechanical cooling, there's an economizer check. And if the outside air is below 59 degrees, it'll bring that air in for free cooling. But if it's above 59 degrees, it's going to shut the economizer damper and it's going to run mechanical cooling, which of course is an energy penalty. What we're doing, because we have visibility to the supplier of the return air, we're going to employ a pretty basic differential economizing sequence where at the end of the day, we're never going to allow mechanical cooling when the outside air temperature is lower than the return air temperature, even if it's above some arbitrary set point like 59 degrees. So we're able to maximize the use of outside air as a free cooling resource beyond the basic economizer function. And then finally, we do a basic demand control ventilation sequence. We're continuously monitoring the concentration of CO2 in the return air section, and when we know and can determine that the zone is unoccupied, we can do things like slow the fan down and shut dampers into that until that occupied condition changes. So when you add up these three layers of sequences, fan speed operations, enhancing the economizer function, and the DCV, that's how we get to what we typically promise to our customers is anywhere between 25 and 50% savings. Questions? Does that make sense? Okay, perfect. So again, we talked about all of this kind of in the context of a standalone. So we do have a catalyst solution that can be deployed as a complete standalone, as a slave to an existing control. Again, it could be a PMS, or it could be a thermostat, but there's certainly a lot more value to we don't want to just make these smart and efficient machines. We want to make them smart, efficient, and connected machines so we can create more value. And that's really kind of where this IoT and all this infrastructure comes into play and starts to take shape. So what I'll do for a moment here is describe exactly how we do all of that from a technical perspective before we start to talk about kind of the value of doing all this for the end-use customer and for service providers alike. So what we're basically doing here, if you look at this, it almost lines up perfectly in these four squares. This is great. So assume that this is someone's rooftop. I've got 4 rooftop package units. I've installed the catalyst in each unit. And that catalyst is actually intercepting commands and optimizing those machines for energy conservation. But part of that package is also some wireless radios. So what I'm doing first and foremost is I'm creating a non-discoverable wireless Wi-Fi, so it's high band network among all of these units. I'm going to start the communication there on the rooftop. From a topology perspective, it's not a mesh network. It's basically a hub and spoke. So what we do is we select any one of these units, usually the unit closest to, say, a utility closet or a network router inside the building, to become what we would call the central access point. And what happens is all the other units will communicate in real time through that central hub, which we call the central access point. So that's the first kind of network that we're employing to deliver this round-trip connectivity. So the second thing that we need to do is we need to get connectivity between the rooftop, that access point, to our cloud, because that's where a lot of all the processing and all the applications are delivered to the customer is through web-based applications that are served by the cloud. So there's a couple different ways that we do that. We can do that with mobile Wi-Fi. So in some cases, we'll deploy a mobile Wi-Fi modem, and it's great. It's fairly cost-effective. The only thing that if it's a small business customer, maybe the ongoing charges they're not completely in love with, but in the scheme of things, it's worth the value that they're getting in terms of our energy conservation, building automation. But what most of our customers do is just run a network drop up to the central access point. We plug it into a Chase, and we basically set up a VPN and tunnel right through normally open ports in their firewall. And we communicate out to the cloud that way. So you're probably saying, oh, my customers aren't going to let me do that. Well, they actually, the way that we do it, and I'm not an IT expert, the way that we do it is fairly benign, and we've done it, again, with 95% of our customers, including some of the ones you saw, like the Navy. So it's pretty secure. Like Eli Lilly, they're fanatical about their IP, and they don't want any other packets on their network. But then they saw our spec, they were like, oh yeah, okay, you can do that. So if you have any other questions about security, please see me after, and I can kind of point you to the direction of some resources and some people who can talk to you much better about that than I can. Okay, so we've got connectivity in the rooftop, that's one network. We've got connectivity to the cloud. And then finally, what we're able to do, once all this data is in the cloud, we can create these custom control and monitoring sites for our customers. So here I'm kind of giving you a couple of screenshots, I'll show you more. But at the end of the day, we're giving the end-use customer and their partners, by the way, fairly ubiquitous access to their rooftop assets with a browser on any device, whether they're within their enterprise or whether they're at home or out of the country. We're able to give them this information, and this information has specific value. We'll get into that in a moment. Any questions about this and how all this stuff works? Good? Okay. Okay, so let's find out and discover, or maybe discuss, what is this advantage? Why is this connectivity so important? So there are a few things that come to mind, and there's much more than this, but I'll go through a few of them. One thing I want to point out right away is that a lot of people really like this whole idea of building automation in the cloud. Now, we didn't go to market with our solutions with that in mind. We actually kind of came to market, we can save people a lot of energy. That's where all the value is. Well, as it turns out, there's a lot of other value. And most of our customers, or some of our customers anyway, once they start using our cloud-based automation system for their heating and cooling, start asking us and tapping us on the shoulder, I got a lighting panel, I got a boiler, I got some exhaust fans. Is there any way we can control that stuff with your EIQ, your thing, your catalyst? And the answer is yes. It's all a matter of simple input and output. And we do this quite often for our customers. We provide custom graphics, and they can control other things in the cloud in addition to their heating and cooling. So that's one reason why this connectivity is important. For many, many years in energy conservation, we've done a lot of standalone measures. The utilities have incentivized widget types, ECMs, and we're thankful that they did. But at the end of the day, over the course of time, I think we've all come to discover that, we're not really saving as much as we thought we would, and there's a bunch of reasons for that. So this whole idea of measurement and verification is obviously important. You guys probably talk about this a lot at AEE, so the value is pretty obvious. In some cases, we can't even get incentives for projects without M&V in some utility territories. So sometimes we won't even be able to capture energy conservation without meeting this requirement in order to get the incentive that would buy that investment down sufficiently so that they would actually do it. So this is built into our system. So the minute that someone installs the catalyst with our EIQ system, they can know instantly how it's performing, and they can know how it's performing over time. System reporting. So there's a lot more things going on besides just energy savings and energy conservation. What's going on in the building? How are these systems operating? when am I heating and cooling my building? Why? So we give the customer the capability to know all these things in a very granular way in terms of data. Because we're connected, we're able to do things like automated demand response. Now, I don't believe that we are an auto DR market here in the New England ISO, are we? We're not. So that's probably coming at some point, and we're doing it in other places like California. I know we've got an auto DR site in Hawaii and one in the Pacific Northwest. But there's value here, without going into it. The hardest thing to do to capture, to enable automated demand response, it's not the underlying subsystems, it's always the connectivity piece, which is the barrier. Ask any aggregator. So because it's a connected solution, we're able to very easily integrate with automated demand response systems, regardless of what the protocol is, whether it's some Aeronaut or some other aggregator. They have a proprietary system, or we've got OpenADR in California. It's easy for us to make that data handshake and deliver robust curtailment using our catalyst system below our catalyst efficiency baseline. And then finally, a gateway for building the grid transaction networks. I'm not even sure I know what that is, but I think I know what it is. And at the end of the day, if we look even further down the road, people will be trying to do price demand response. A lot of energy markets are deregulating to real-time pricing tariffs. People are doing energy arbitrage. So again, this connectivity gives us the capability to do not only the curtailment that we need to do to take advantage of these opportunities, but the connectivity that can happen efficiently. And then finally, and I think most of the value that we recognize today is really in the area of fault detection and diagnostics, and that's why I'm going to kind of spend a little extra time on this. So I want to confuse you even more about how this catalyst works. I already described that it can be a complete standalone, which it can, or as you can see, it can be, we can take over the system in terms of the control. So instead of having RTUs with catalysts connected to thermostats and BMSs, I can kind of disconnect all those things and have all of my automation live in the cloud, including schedules and set points. Now, that may be fine or great for a lot of customers, but some customers are actually invested in their building automation. And we don't ever want to tell the customer, no, we can't give you energy conservation because you're running a Siemens Avtry system or a Johnson system. So we can actually, at the same time, be a slave to an existing control, which pretty much owns set points and schedules, and also give, in addition to what the automation system provides, fault diagnostics and these other things. So I can still give them this console and this data without having to abandon an existing control. So they can exist, they can coexist. But where they don't coexist, one of the most important things is really schedule persistence and set point persistence. If you ever talk to anyone who operates a building where they have thermostats everywhere, that's like the Wild West, because they're building occupants have access to the thermostats and know what's going on half the time. So it's very valuable. We can give that to them in the cloud. Economizer fault detection. I'm going to actually show you the console. I don't even know how it works because we just released this and you'll see it. It's very powerful. And that is probably the number one point of failure for any of these units. The actuator's not working, the linkage breaks. Someone literally sticks a 2x4 and I've seen it all, and I have been doing this for a long time. So when those economizers break, even worse is that we don't know about it until the next time a PM happens, because if the economizer breaks, it's going to run mechanical cooling to overcompensate, so it's going to be more expensive to repair, it's going to be more expensive to operate, and it's not even going to manifest in a comfort issue in the building, so we're not going to know for a while. So again, the power of fault diagnostics allows us to lower our O&M costs, and we can use the EIQ to remote test and calibrate, and do a number of other things, and you'll get a sense of that when I show you screenshots of our console. And then there's some advanced opportunities in terms of outlier identification. All the things and all the faults that we detect may show us that things are kind of working as designed and normally. But particularly with energy use, what happens when we notice a trend where one unit, one area of the building is suddenly spiking in energy consumption? Is it a problem with the equipment? Is there something changed in my building? I might not know, but without buyer identification, which kind of falls into analytics, I can at least let the building operator know, hey, no worries, but by the way, something may be going on here, so you may want to investigate. So I think this aspect of our solution will evolve over time as we start to understand relationships between the assets that we control and maybe interrelationships between other systems that we control. So that's important as we look forward. But at the end of the day, these fault diagnostics really will lead to a persistence of savings, and that's the key. I think I'm going to talk a little bit about this toward the end of my presentation, but if we're trying to do energy conservation, we're making these investments, we need to have a way that we can measure it, and we also need to have a way that we can guarantee to maintain those savings and that value. Okay, so what I'm going to do right now is kind of go through just a couple of our screenshots here. So a big part of this is visualizing things. So as you can see, if you were to have one of our systems and you log in, you can drill down into any one unit and see pretty much everything that's going on. It's actually really pretty. The fan actually looks like it's moving, even though you're using a browser, and it shows you all the different temperature points, unit power, what's going on in the unit. Am I heating? Am I cooling? Am I ventilating? And so on and so forth. I can take more of a high-level view, and I can look at a site. So this is one of our Staples stores, and you can see they have 8 rooftop package units. Each is represented by a globe here. And even in this view, we're giving them basic information about what's the fan speed? Is it in cooling mode? What's the temperature outside? What is the energy use? And then I can really drill down into more detailed information, more of a line item format. All this information, by the way, can be exported into various file formats. I can write reports, and I'll show you some of this in a moment. And then, again, going back to fault detection, we like to be very verbose about our fault detection because it's very important. So if a building operator or a service provider logs in, they're able to know that there are different faults. And they can actually click on these faults and they'll open up new pages that have wiring diagrams, troubleshooting information on trying to remedy those faults. So it's all about information. It's all about information in context. So again, we have ways that a service provider or a customer can remotely test and do preventative maintenance. Not all of it, but a lot of it. So we're providing tools there. Building operators have complete remote control capability. They can reset the units. They can adjust schedule set points, outside air damper positions, set their fan speeds, their economizer lockout, and so on and so forth. So you can see, it's a little bit of an eye chart, but there's a lot here. We want to give the customer the capability to do everything that they need to do remotely. And then here is our brand shiny new, and it's based on what Title 24 is making us do in California, is our economizer fault detection console. So obviously this is a very important aspect of what we do. And then in terms of data, it's not just about energy conservation and energy use and energy reductions. For a building operator, it may be about heating and cooling hours. And when are we doing it? How much are we doing it? And where is the heat? Where is the cooling coming from? Compressor-based cooling, or is it economizer-based cooling, or is it a mix? And when and where? This is important information for a building operator. In terms of energy conservation, well, okay, outside air temperature. What is my cost before? My cost after for operating the unit? All this data can be kind of sliced and diced and churned as the customer needs. And this is kind of our portfolio view. I'm actually going to come back to this in a moment because it's a good example of something. So before I move on, are there any questions about our solutions, both from a hardware perspective and this EIQ, this cloud-based monitoring and or control and or BMS opportunity that we present to our customers? Does that make sense? Yes.
How many sites or units do you have up on the platform?
Tens of thousands. Yeah. Sorry, I'm based on an exact count. Cool. Anyone else? Any other questions, comments, observations? All right. So to wrap things up here, and the whole point of this presentation is to kind of show how IoT is really setting the stage and setting the conditions for companies like mine and other companies to bring value to the market. And I hope that I've been able to do that. But to try to put a finer point on this, I mean, obviously, the IoT and our catalyst is making it possible for some pretty robust building automation that probably wouldn't be available to a lot of customers in a traditional sense, right? So, you know, we have customers, large customers, and we have small mom and pop operations that use these systems. You know, I don't see a convenience store or a small retail outlet having the resources or even the capability to accept and own traditional automation system, yet they still need that value just as much as a large enterprise scale customer. So we make that possible, and one of the reasons why it's possible is this Internet of Things, that infrastructure. Again, this built-in measurement and verification is very important. I'm not going to talk about that again. And again, you know, having all of this allows us to deliver. If people are after energy conservation, even if they don't see any value in the building automation, because make no mistake, I just showed you a bunch of fancy screens and stuff like that. Building automation isn't about a guy coming in and sitting down at a desk every day and rocking the console. This is set it and forget it technology. They call it automation for a reason. Someone shouldn't have to be in there ever. And part of our solution, by the way, I failed to mention, has a very robust and granular alarming system. So also ties into IoT, right? So we're able to message and send information out for fault diagnostics and other reasons, energy outliers, you know, that you can get on your phones, you can get on your computer, so that you're not constantly just logging in and looking at things every day. I don't have time to do that. I don't think anyone has time to do that. And then finally, and this is kind of interesting to me, being in the energy conservation world for a long time, to see how many people are actually coming to us, not for energy conservation, but to replace antiquated BMS and building automation infrastructure. I mean, there are a lot of customers that have these systems that cost a lot of money just to keep their buildings running. A lot of these systems are sold, they can't even find replacement parts. And they're coming to us because they heard about our EIQ, and we kind of give them a get out of jail free card in a lot of cases. We can remove old antiquated controls at a very, very low cost. And in fact, for the cost of doing energy conservation, which is largely incentivized by utilities. So it can be a kind of a win-win for the customer. They get two things in one. That's pretty important. And then finally, so now I want to be careful. I am not an engineer. I'm not a building engineer. I'm not an analyst. I don't want to offend anyone's sensibilities here with anything that I may or may not say. And I'm the dumbest guy in the room here, make no mistake. But most of the things that I'm telling you, or that I'm about to tell you, are things that my customers are telling me. So I'm just going to rely on that, and we can all debate about this at a later date. But I think it's pretty clear that historically, this proprietary nature of system has prevented innovation, which it always does. And I recall about 10 minutes ago, half the people raised their hands and said proprietary is bad. Well, this might be one of the reasons why it's bad. Or not bad, maybe it's too strong a word, but maybe not good. Maybe it kind of impedes our progress. So I think the IoT in general, is disruptive. It's going to change things for the better. So problem is that sometimes that upsets the status quo. But of course, there's nothing preventing the status quo from embracing the IoT and innovating in their own way, which they certainly will do and are doing. One of the things that the IoT does for us is allows us to do rapid user interface development. I'm going to give you an example of that. So we have a customer in the Pacific Northwest, Bartell Drugs. They have 60 retail outlets. They all have the Catalyst, and they love our saving a ton of energy. All their facility guys and regional people use it. Their service providers have access to it. Everything is working great. We talked to their VP of operations, and we asked him, what his thoughts were. And he says, "I hate it." I'm like, "What do you mean you hate it?" He's like, "This EIQ thing that you guys are always raving about has no value for me." And we're like, "What are you talking about?" He's like, "Look, I don't have time to sit down. I have 60 stores. If I want to see what's going on into the faults and stuff, I don't want to get alarms all day. That's what my facility guys, my other guys do. But there are some things that I'm concerned about. All I care about is I want to open up the newspaper and read the headlines. I want to know about what's going on in terms of energy in my stores. I want to know what's going on in terms of how the equipment is operating, and I certainly want to know that everyone's comfortable. How do I figure that out? So after getting that feedback in about a month's time, I'm going to go back. We created this portfolio view for our multi-site customers. So here, when this person logs in, this is what they're going to see. And across their entire portfolio, I've got 3 buckets of information for him, that he can act on this information or not. Here are all the things going on in terms of energy. Here are all the things that are going on in terms of health. And here are comfort warnings in any of my buildings. Now, for 60 sites operating rooftop package units, this is a pretty clean system going on here with this few, warnings and alarms in these 3 different buckets. But again, the point is that because this is a cloud-based system, because of the IoT, we were able to deliver significant value for a very important customer of ours in a very short period of time, and at a low cost to us in terms of development. And then finally, a couple more things. The IoT is going to change relationships. We believe, and it's certainly changed relationships in a couple different ways with our customers. One is that with these types of tools, we allow information to get to other stakeholders with the end user. So usually it's only a facility manager that has access to a BMS, and usually that information is really tailored for his purposes. But with systems like ours, we're able to quickly provide data to and give visibility and context to data for a COO or even a VP. So now when something's going on in their building, everyone kind of is on the same page. It's not like I have to rely on this subject matter expert to have a general idea of what's going on in my building. So it changes the relationships for the end users. And it also changes the relationship between service providers and manufacturers and their end users. So, for example, when Whole Foods first started taking on the Catalyst, they really didn't have everything set up in terms of their own maintenance and how that was going to work. But we were getting reports every day. We got a failure in this store. You got an economizer stuck over here in Hawaii. We were, just as doing them a favor, we were saying, hey, by the way, we noticed that these faults have persisted for more than a day. You might want to go log in and take a look. They were astounded by all this information and how accessible it was. So it's certainly changed the relationship between manufacturers and their customers, because a lot of the time this customer is really not our customer, it's someone else's customer that brought us to market. But at the end of the day, we can be there way back behind the scenes to support both them and one of our channel partners that actually delivered the solution to them. Whole Foods isn't a good example, but many other customers are. And then finally, I think you're going to start to see a shift from traditional building automation, where there's a lot of hardware, pipe and wire, processing that happens at the site, to more platform as a service, which is kind of similar to software as a service, which we've sort of seen take over. And that's really what we're doing. We're offering platform as a service, and I think it will lower the cost of ownership of building automation for everyone, but I think it really broadens the opportunity, because again, a lot of companies and small businesses don't have the economic resources or resources in terms of even really own and get value out of these systems. So these are the areas where we see the IoT really having an impact as we look forward. And that's all I have. Are there any questions? Yes.
Do you also look at the pressure drop across the filter bank, because that's a second area of maintenance that doesn't get done?
I don't know the answer to that. I can find out for you though. See me after, please.
Oh, sure.
Yes.
Where are you guys going after rooftops?
That's a good question. All right.
There's a lot of them out there.
I gotta be careful. So first things first, you may have heard or may not have heard, it doesn't matter, that we were a fairly significant company before what I'm about to tell you happened. So I think the holding company that owns Transformative Wave is something like $500 million a year revenue. So we're not just some startup. And by the way, this Catalyst solution was born on the rooftop. So a company called the Performance Mechanical Group, which is a large design build energy contractor in the Pacific Northwest. This Transformative is a spin-off of that company. So we've been doing this for a long time. We finally decided, hey, there's a lot of value here. We talked to utilities, DOE, they're like, there's a ton of value there, bring it to market, which is what we did about 10 years ago. but we were a pretty big company. But 2 or 3 weeks ago, Emerson came in and took a fairly significant equity stake in our business. Now, Emerson has a market cap of like 33 billion or something like that. So at the end of the day, it was a good thing for everyone because people who were equity partners, I wasn't, unfortunately, got paid. We still control our business, and now we have all these resources and economies of scale and brains that we can rely on, in addition to our own brains, being partners with Emerson. So where are we going next? That's a very good question. I think it's fair to say that the long-term opportunity for Transformative Wave is not in the catalyst, it's in the EIQ, right? It's going to be a matter of, okay, so now we've got this kind of turnkey module for this building subsystem. Well, when are we going to have one for a boiler? Kind of plug and play. When do we have one for a lighting panel or a relay panel? Maybe that's some of that stuff that's coming. I can't confirm or deny, but I think that's probably what the trajectory of our business looks like in terms of solutions.
And that'll sort of tax you because you're working within a fairly narrow subset of equipment types. So you can,
absolutely.
So once you start going outside of that subset, the range of possibilities expand dramatically.
Fair enough, and one follow-up comment before I take your... I mean, the good news is for us is that, again, there's a preponderance of buildings that heat and cool with packaged units. Not all of them are going to be the best candidate for the catalyst. If they're big units, long runtime hours, manufacturing, retail, all kinds of weird niche markets, call centers, and health clubs, and YMCA's, and that's great. But a small, like a small office complex, right? Like a little 5-ton units, they're not in there for a long time. They're in there Monday through Friday, 7 to 5. We'll still save, and we'll still reduce energy by like 25 to 50%. But it's just not cost effective. It is, and it isn't. It's not going to be like the no-brainer, less than 2-year payback for that customer. But for a lot of the customers you saw, yeah, it's compelling. But what next? So I think you're right. It'll broaden our opportunity for cloud-based control. Again, we didn't really get into this business for that. We were in it for the energy conservation, this RTU thing that we had. We had domain expertise in it. So thank you for that observation. Yes.
Just a question, when you look at the multi-site space, it's certainly underserved in terms of energy. Do you see like an integration path with the big players like Honeywell and Novar, or do you see yourselves pushing them out more?
We're pretty agnostic, right? So let me try to answer that question by giving you an example. So we do have customers that want energy conservation. They want the catalyst for what it is, right? They also want all this information, fault diagnostic, and the things that we have expertise in terms of this class of equipment. But they don't want, they want to own all that data. They don't want all this stuff in the cloud. So one of our turnkey solutions is basically, what do we call it? It's a catalyst, VMS, whatever, because we don't do it a lot. But some customers want to own all that data, so all we do is give them our standard catalyst offering. We do design build kits. And instead of having everything in the cloud, we put a JSON there, and basically all that data is local. They own it. So they can decide to actually just get visibility into the JSON, so they can just use, they can get that data through to a VMS, and we give them an SDK and an API, and they can do whatever they want with the information. So that's what we do now. Yes.
Typical all-in costs. Pick a size between 3,000, 5,000.
I can't give you that. Here's what I can tell you. A catalyst kit could cost anywhere from $1,700 per kit to $7,000 per kit. And it depends on a number of things. One, the size of the unit, because that really depends on the size of the drive, the cost of the drive, what options there are. Sometimes you'll actually have to do active dehumidification, which requires more sensors. And a lot of these units aren't as simple as I described them, where there's just a fan and a heating and cooling plant. Some have heat wheels, all kinds of crazy stuff. Some have zone systems. So it depends. So
a typical rooftop office unit, 3,000 to 5,000 CFM, 5 to 10 tons.
maybe a couple grand. And it might
install everything.
No, maybe a couple grand for the hardware, maybe another, I don't know, $1,000, $1,500 in labor. So then you've got some incentives. You can take it's hard to do that calculus for you, and because I don't want to. I will be honest with you and tell you that a again, small 5 to 10 ton units with low runtime hours, whether it's an office or anything else, isn't going to light the world on fire in terms of simple payback. It's a terrible way to look at the value. But if that's the way we're looking at it, it's probably a 5 or 6 year payback for something like that. Now, a manufacturer with 20 ton units operating extended hours, say 3,500 annual hours plus, 1 year simple payback maybe. So there's huge opportunities. If we're just trying to get quick and cheap energy conservation, we can do that. But again, we think it's more than that, because there are plenty of other people that have drive-only type cheap widget solutions for rooftop packaging. And we actually make one too because the market demands it. We hate to sell it, but we will. But most of our customers, again, are taking on some form of this EIQ because they can see the value of this data. Even if they have an existing PMS, we can give this data to them in addition to that without unplugging it. I'm sorry, again, I really can't answer it the way you want to. It's not a widget type solution. Yes?
Yeah, if it's something like a Whole Foods who, is standardized on Transformative Wave for their rooftops, then he's got his freezers and other things going on, and he's concerned about demand response. So is your database open for him to pull data out of, to combine it with other databases so he can make it? So
it is. Because, certainly, I think Whole Foods is probably a good example of that, right? I don't want to misrepresent what we're doing for a customer like Whole Foods. I'm pretty sure, and I don't know if it's a national account customer, I don't really deal with it, but I'm pretty sure they probably have like a Seasons 4 control system there, which I don't know a heck of a lot about, but it controls refrigeration and all kinds of other things that are maybe even more vital, arguably, to the customer experience and the things that they're trying to do there, sell food. So I know that some of the sites we've actually integrated some of that data with, as a pilot, but most customers that have existing BMS infrastructure that's still viable or still has value for them, it's easy for them to just accept its additional information without having to tie the two together, because a lot of these systems already have web front ends. So how hard is it to just click a link and just get information over here? So long as I'm not trying to do analytics, you know what I mean? I can have pretty easy access to both through a browser. I don't know if that really answers your question.
Yeah, he may have some analytics that he likes better than yours for whatever reason, or he may be trying to do something where he's adding one and one together. But so your platform is open, so he can pull data out of there. You have open APIs.
Yeah, so like I said before, a lot of customers don't want anything to do with our cloud presentation.
Yeah.
They just want all the data.
Yeah.
So we give them the JSON, we give them all the data, and we even give them the graphics so they can kind of do some rapid development on the BAS side. So if they want to do that, they can do that.
But some people in the organization may love what you have, but some other people may be trying to do something else.
Certainly.
So you're open to.
And this is all of our backend stuff is Tritium based.
Yeah.
So it's all open source and just buy licenses. And I know we're doing some other stuff with.
It's open source Tritium, because Tritium's not always open source.
Right. And we're doing stuff. So if you heard about Voltron, it's an open source standard that the federal government's trying to put together. We're doing stuff with that, so it's all fairly open, easy for customers to take what we have and do whatever they want with it. So we're happy to do that for them too. So
That just brought up an interesting question about demand response. Is that part of your sort of package of applications that you have within Catalyst that you can accept the demand response mode?
It is, right? So now when we talk about demand response, let's put it into context, right? So the first thing that we're doing, right, is energy conservation, right? So we're going from some load and some consumption load, right, down to something new. That's what the Catalyst does out of the box, right? When we talk about demand, so that's the new energy baseline. When we talk about demand response, we're talking about further reductions, but they're temporary reductions, right, below the efficiency baseline. So that doesn't necessarily have to be automated like we spoke about. It can be some customer manual initiated. So we do have that as an application that you can purchase. It doesn't really drive up the cost. It's more hardware that goes into our kit. So yeah, it is an application that you can get right out of the box. And what basically we will do is we can either respond to a signal through the cloud and tie that up from a data perspective, or we can give the customer a button in their EIQ console that says, go into curtailment mode, we give them the tools to configure the parameters of that curtailment. Generally speaking, what we're able to do, and again, we haven't done so much of this that we can stand very firm in what the value of this is, than just the curtailment. We're pretty much able to, in all the climate zones that we've done this, curtail the energy load in terms of kW by about 15 to 20% and hold it down for about 4 hours, which I don't know that there are any other demand responses that's a lot longer than that. And we do it in ways that you would expect that we would. There's a pre-cool, there's a set point shift, and then there's a duty cycling thing that happens. But it's pretty reliable and robust, and they can do it manually or they can do it through auto DR. Okay, thank you very much.
Great.